Hello, and look at what I picked up last week. Yes, an IBM luggable. Not the 5155, but this is a luggable from the IBM PS2 line, the P70. Model number 8573-121 to be exact. And just look at it when I open her up. It's got this nice detachable keyboard. You can pull it away from the PC completely and have it on your desk like this. It's a bit plasticky and not Model M quality, but it does have a nice clicky feel to it. The display can also be tilted towards the user, as otherwise it would stay pretty vertical due to the positioning of the case. So just look at it. Isn't it a beauty? Well, it would be if upon starting it would actually do something, which it doesn't. So when I flip the switch, nothing happens. No beeps, no error codes, nothing. The power supply fan kicks in and the power LED goes on, but that's about it. Sometimes I do actually hear error codes coming from the PC speaker. One long beep followed by two short beeps, indicating a problem with the video. And sure enough, nothing is displayed on the plasma screen. The unit comes with a 1.44 megabyte disk drive, which is located here and it slides out from the top. I tried booting from an MS-DOS boot floppy, but nothing happened. So aside from the occasional beep, the machine stayed pretty much dead. Nothing came on the screen, there was no life into it, so we needed to open her up. Now, opening up the P70 is actually quite simple. It only takes 3 screws that you need to unscrew in order to get to the internals. So there are 2 screws at the bottom. And there's one hidden screw in this little compartment here, where we have the serial port, parallel port, mouse port, and VGA port. And once this final screw has been removed, we can gently pull off this cover here and look at the internals. So this is actually just a desktop PC that they have put into a luggable format. We have the power supply here at the bottom with the fan. That apparently needs a bit of a cleaning. We have a hard drive here, which is of type ESDI. We have the main board with a Intel 386 DX20 MHz CPU. We've got 4 SIM modules making up 8 megabytes of RAM. And we have a kind of a riser card with an expansion slot. A 16-bit microchannel architecture slot and a 32-bit microchannel architecture slot. And on the top here we have the video card. With the plasma connector for the plasma screen on one side and a VGA output on the other side for an optional external display. So I'm going to be using some compressed air to get the cobwebs out of the system. And let's take a closer look at the board. Somebody lost a heatsink in here. I don't know where that came from. At first I thought it would be an issue with the plasma screen connector, which is located here on the video card. I actually pulled it out and cleaned it up a little bit, used some compressed air and even some isopropyl alcohol with contact cleaner, but to no avail. The computer would display nothing on the screen. The computer also comes with this battery here located next to the PC speaker in this little corner here. Now these types of computers should normally be able to boot even with a dead battery, so I was expecting to see some error code, so I doubt the fact that a dead battery would be the cause of this computer not booting. But I ended up pulling it out, and yes, obviously it was dead, taking into account that this is a 30-year-old machine. So let's start by disassembling everything. So we'll start with this riser card here. We'll just open it up, detach some screws. Now the riser card is actually part of the assembly that groups together these different I/O ports here, like the parallel port, serial port, the PS2 mouse port, the VGA port, and the external disk drive port. So we'll need to remove some screws here so that we can detach the plate and detach the riser card completely from the main board, like so. And here we can have a good view on the 16-bit MCA or microchannel architecture slot, and on the other side we have a 32-bit MCA slot. Now, nothing is standard in this machine, so although it appears to have a standard AT power connector, the connector coming from the PSU isn't standard at all. It has this 3x4 pin layout, which is pretty strange. Even the hard drive isn't your standard IDE or SCSI interface. It uses an ESDI interface, and these hard drives are pretty hard to come by, so hopefully this one will still work. And to remove the hard drive, we just need to remove a couple of screws here. And as you can see, it doesn't use the standard IDE connector and a separate power connector. It uses these kind of two flat cables, which kind of resembles an IDE cable, but it's not at all pin compatible with IDE. But with all the screws unscrewed, we can gently pull out the hard drive and see that this is an IBM 120 megabyte ESDI hard drive with this huge connector here that exits in these two flat cables here. On the other side of the power supply, we have the floppy drive connector, which looks like a standard 34-pin floppy drive flat cable, but I can assure you that it's not, because this cable also supplies power to the floppy drive. At first I thought that this separate connector here would be the power connector to the floppy drive, but it turned out that this was the power connector for the LED panel which sits in front of the PC. So the floppy drive actually gets its power through this floppy drive flat cable. So this makes it impossible to hook up a standard floppy drive. So there are two screws to unscrew if you want to remove the power supply, because I will be taking a look inside and cleaning up the fan, because it's kind of a dust magnet over here. So we're just going to be removing some ground cables here. And then just when I thought I was able to pull out the power supply, I noticed that it was stuck. And the only way to get it out is to actually open up the computer, pull down the keyboard, and then you will be able to slide out the power supply from the main unit. But let's take a closer look at the main board. I am going to try and remove this main board. So in order to do that, I will need to unscrew a couple of screws and remove a couple of connectors here. For example, this plasma screen connector, we have the PC speaker, we have the battery connector. I've already disconnected the hard drive and the floppy drive, so all that's left to do now is to remove a couple of screws in order to get the entire main board out. So let's go ahead and do that. So here I'm disconnecting the power supply unit from the main board. There are a couple of screws hidden here that we still need to remove. We have the PC speaker, we have the battery connector, we have some ground cables that we need to disconnect. Here we have the plasma screen connector on the video card that should give video output to the plasma screen. And here we have the keyboard connector that we need to remove. And once that has been done, we can slide out the main board out of the case and take a closer look. So here we have a good view of the main board and the video card here, which sits on top. Here we have the slot for the riser card, the Intel CPU, we have our memory, we have the floppy drive connector, hard drive connectors, and some I/O here, including serial port, parallel port, and external VGA port. But let's remove the video card. So here we have it. So this is an IBM branded video card. It uses this connector. The capacitors on the card seem to be in pretty good condition. I did measure all of them and I didn't see any shorts. connector seems to be fine. So here we have the VGA connector to hook up an external monitor. Even these electrolytic capacitors seem to be okay. So I just used some contact cleaner and put everything back together, and now I'm just going to see if the machine will boot. I have it out of the case right now, making it a little bit difficult to hook up the plasma screen, but I am going to be hooking up an external VGA monitor, which has the correct pinout to hook up to this external VGA connector on the video card. So let's power her up. Let's get a power cord in. Let's power on the machine, hook up the monitor, and Lord and behold, we have output on the external monitor. So there is some life getting into the machine, which is very nice. So the memory count goes all the way up to 8 megabytes, which is as expected. And then it will no doubt output various error codes because we don't have anything hooked up to the system. So far so good. I have hooked up the video card back to the main board. I'm going to be putting everything back into its case, because it's a lot more convenient to work with the main board sitting inside of the case. This is not the most flexible machine. The cable length doesn't really facilitate putting the main board out of the system, so I'm just going to be putting it in there, hooking up our keyboard, the power connector from the PSU, the ground for the plasma power, the plasma screen output connector on the video card, the PC speaker, and the 6-volt battery. I also am going to be putting the ground wires back in place, pulling them back to the power supply, hooking up our LEDs and disk drive, and yes, when starting we see the bright orange on the plasma screen popping up. We do have some error codes, which is to be expected, as the dead battery has caused the machine to lose all of its configuration values, and that is something that we will need to set right now, because now it will simply boot into IBM Personal Computer Basic, which is not what we want. Now, in order to get this machine up and running, we need to be able to boot it using a reference disk. Now, I couldn't get this machine to boot at all with any boot disk, so I needed to take the disk drive out to see what was wrong with it. Now, these drives are known to be very error prone and are known to fail quite often. At first glance, this looks like a pretty standard 1.44 megabyte disk drive, but make no mistake, it is not. Notice how it doesn't have a power connector, as you would normally see with a normal disk drive. In this case, the power is actually run through the floppy drive cable, making it impossible to replace this disk drive with any normal disk drive, unless you want to blow it up. So let's open her up and see if we can identify what is wrong with this particular unit. So we need to open up the top case. I'm just going to use some canned air. I'm also going to be cleaning the heads. But I noticed that although the motor is spinning, and it is spinning the floppy drive, that the heads are not moving, and the disk drive makes a certain sound that it shouldn't make. So upon closer inspection, I noticed that not all of the capacitors were bad, but there were definitely some capacitors here that have leaked. As you can see on this image here, the screw has all kinds of gunk on it. The electrolytic material that has been leaked from the capacitors. So this drive is definitely bad and needs to be recapped. Now, I don't have any spare parts here, so I am going to try and modify a standard floppy drive. As you can see here, this one does have a separate power connector, alongside the standard floppy drive cable connector, so we'll need to modify it a little bit. Now, a floppy drive connector starts at the bottom left, where we have pin number 1, then we go to pin number 2, pin number 3, which in this case is not connected, something that you see on a lot of disk drive, as this pin is used to provide 5 volts to the disk drive. Pin number 4 is typically connected, but has a special purpose in this IBM computer. In short, we need to pull this pin to ground. Now, on a floppy drive connector, all of the bottom pins are ground pins, but obviously pin number 4, which sits on the top, is not pulled to ground, so we'll need to do that ourselves. Next up, we move to pin number 5 and 6, and 6 is an important one, because when hooked up to an IBM P70 machine like this one, 12 volts will be put on this pin. And let me assure you that most modern disk drives will not be happy with this. But let's start with pin number 4 that needs to be pulled to ground. So I'm just going to be using this jumper wire here to make a connection from pin number 4 to any of the ground pins below, for example this one. So that will ensure that pin 4 is always pulled to ground, and that's good for this computer. Now, pin number 6, which we don't want to put 12 volts on, we're just going to be removing this pin because this is a 5 volt drive. We're not going to allow the IBM computer to put 12 volts onto this disk drive. So we're just going to be removing the pin completely to avoid that. Now, the disk drive does need power, so I am going to be using this Molex connector here to get 5 volts from the IBM power supply and then route that to the modern disk drive. And that should hopefully allow me to boot the reference disk using this modern disk drive. So let's try it out. Fingers crossed, and let's hope this works. So we can clearly hear the floppy drive seeking and booting the disk drive which has been inserted. And hopefully after a couple of seconds we should see the beautiful IBM logo in bright orange on our plasma display. Now, the first thing the reference disk does is warn us about a potential issue with the battery, followed by the explanation of error code 161, which is the battery error. Now, the reference disk will start an automatic configuration process to put the computer back into normal operations. And hopefully the error 161 should disappear after this auto config has been run. So we'll go ahead and do that. And once the auto config has been done, a quick reboot is sufficient to see if the error code has disappeared. So after a reboot, the 161 error is gone, and we were left with just one more error code, which is 163. And according to the reference disk, error code 163 means that the date and time has not been set, a result of the dead battery. But luckily, it's pretty easy to set the date and time using the reference disk, so we'll just go ahead and do that. Now, the reference disk also contains testing software to test the various components in the system, like the system board, the screen, floppy drive, hard drive, and so on. So we'll load up these tests to see if the machine is working properly. So we'll start by testing the system unit, which is completed. We can test the memory. So some of these tests actually take a very long time to complete. The overall testing procedure was like 30 minutes. So I did fast forward here a little bit. We can test the keyboard, as you can see here. We can also test the I/O ports, like the parallel port. It includes a fairly exhaustive floppy drive test, where it will actually do various speed tests, read-write tests. It even tests the write protection mechanism of your floppy disks. It will also test the serial port, the mouse port, and it also does an exhaustive test of the ESDI fixed disk. I'm really hoping that this one will work, as these are very difficult to come by, but yeah, it seems to be working just fine. And finally, it will do a test of the video card and the plasma screen. And that also seems to work fine. So now we can reboot the system and hopefully get it to load off the hard drive. And sure enough, MS-DOS is booting from the hard drive and Windows for Workgroups is starting up just fine. So I'm glad I got the machine booting again and finding out that the hard drive was fully intact. I did put the modified disk drive into this case here. I rewired the power connectors onto the floppy drive headers, so I put the ground cable here and rerouted it to one of the bottom ground pins, and I took the 5-volt pin from the Molex connector and added it to pin number 3. So all power can now be routed via the floppy cable. I added a pin here for the 5-volt line, and we don't need to use the Molex connector anymore, so everything will fit nicely into the floppy drive bay of the P70. So this is working really well. We can insert our floppy disks here. We can read everything just fine. The only thing that doesn't work is the eject button, because this has a very specific form factor and it doesn't really fit on this floppy drive, so I'll need to find a solution for that. But that's for a future video, so I hope you liked it. I really enjoy working with this machine and I hope to see you guys soon with lots more content on it. Bye bye.